So today we're going to talk about the graphs of sine and cosine. You're on page 350 in your book. Okay, so before I forget, let's write that down. Okay, so the graph of sine and cosine, okay? So the graph of sine goes like this, and I've drawn this several times already. It's like this, and okay, so this is 1 and -1. So the graph starts at 0, 0. So because when we are at, wait a minute, we forgot to do our quiz. So let's go ahead and do our quiz first. And actually, we'll do the quiz later on. So let's go ahead and do this first, and then we'll do the quiz later on, okay? So, sine function goes from 0 up to at pi or 180, comes from here, goes to 0, and then goes back down here, and then at 2 pi, we're back here, so this would be pi, and this would be 3 pi over 2, okay? So this is what the graph looks like. So can anybody tell me how we would classify this graph? So this is y is equal to sine x. Is this an odd or an even function? Anybody?
Is it an even function?
If it's an even function, that means it is symmetric across the y-axis.
Oh, I see.
And that is not the case. It is an odd function because it is symmetric across the origin. Okay, so it's an odd function. It is bounded upper and lower, right? It's bounded upper by 1 and bounded lower by -1. Okay, it's always going to be between 1 and -1. Okay, so it's bounded. Let's see, there are no asymptotes, and it's continuous. So that's about really what we need and what we want to know. Actually, the domain is what? What's the domain here? The domain is all x's, right? It can be anything here, whereas the range is going to be what? Between -1 and 1, right? Because it's bounded upper and lower. Okay. So that's the cosine, that's what the sine function looks like. The cosine function is fairly similar, except that in the cosine function, it's going to look just like the sine. But we're going to start from here. Okay, so it's going to be 0. Two pi, so this is why, so cosine now. Cosine acts the same thing though, it is bounded -1 and 1, okay? Just the starting points are different, because when cosine 0 is 1, goes from 1 and it goes down like this, and it comes back up and it goes like this. So from 0 to 2 pi, was there a question there? Okay, so 0 to 2 pi, so it goes from 1 to -1, and then comes back up to back to 1. Okay, so this one is not odd. This one is actually an even function, right? This is an even function because it is symmetric across the y-axis, right? So it's an even function. Again, it's bounded upper and lower, okay? The domain is the same. Domain is all reals. X can be anything on the real axis, right? On the over here. And then the range, again, is bounded by 1 and -1, okay? So that's the cosine function. All right, so let's go to page 352 now. In 352, we have a definition of a sinusoid. a sinusoid. Function is a sinusoid if it can be written in the following manner. A sine bx plus c plus d. Okay? So this is what it looks like. So the first function that we looked at, y is equal to sine x, has a value would be what? What would a be here? Olivia?
What was the question again?
So this is a sinusoid. That's equal to a sine of bx plus c plus d. We just talked about y is equal to sine x. So in this format, what would the value of a be to satisfy this?
I don't know. 1, maybe.
1, right? It's 1, right? Because there's a 1 here you can't see, right? Right? What would the b value be, Olivia?
Wouldn't it? Wouldn't it? 1,
1 again. C would be,
0,
and D would be
0.
good. Great, thanks. Okay, so that's how that would work. It was the same thing with the cosine. Well, we'll get there. So I don't want to confuse you yet. Okay, so here we go. So definition underneath there, the amplitude of the sinusoid, okay, is A. Okay, so A, this guy here is called the amplitude. This is the amplitude. Okay. And then we're going to talk about let's go ahead and talk about the period and frequency here also. Period is the amount of time it takes for the sinusoid to replicate itself. Okay, so in other words, this was sine x, y is equal to sine x, right? This is y is equal to sine x. It took from here to here is when it replicates itself, right? And it starts anew, right? It starts the same way again, right? So from here to here this was 2 pi. So the period for this graph must have been 2 pi, okay? So the way you find the period is you go 2 pi divided by the absolute value of b, okay? And now again here, we said that our b was equal to 1, so our period would have been 2 pi, and we just verified that yes, indeed, it is correct. So the period is this, okay? A frequency is nothing more than the reciprocal of the period, okay? So I tell you, so it's going to be basically b over 2 pi. Okay, so the period and the frequency are reciprocals of each other. Frequency is the amount of cycles. This is one cycle, right? The amount of cycles that can be seen in one time period. Okay. All right, so let's go to page 353 on the top. It says the period of the sinusoid is 2 pi over the b, and graphically it is the length of one full cycle of the wave. We talked about that, the length right there, right? And then in the middle there's a frequency of the sinusoid, where graphically the frequency is a number of complete cycles the wave completes in a unit interval, right? In a unit time period, in a certain time period. Okay, now let's see if we can do some of these examples here, okay? All right, so example number 1. Example number 1, find the amplitude of each function and use the language of transformation to describe how the graphs are related. Okay, so you have A, y is equal to cosine x. The amplitude here is going to be 1. We already discussed that, right? Okay, so B, if you compare this to y is equal to cosine x and 1/2, okay, all you're doing is you're taking everything that you had here, the cosine x, it looks like this, and you're multiplying it by 1/2. So instead of this guy being 1 here, it's going to be 1/2 now. And this guy here is going to be negative 1/2. So what did you do? You vertically shrunk it by 1/2, right? Okay, that's what you did. And if you have y is equal to negative cosine 3x, okay. So we started with 1. Okay, we're at 1, 1 here, right? But over here, I'm going to go 3 and 3 now, right? But I'm going to go negative, so it's going to look like this, right? The graph is going to look like this. Negative 3 and 3. Okay, all right. So if you look at that, what does it say? It says the vertical stretch by a factor of 3 and then reflects it across the x-axis. So you vertically stretched it by 3 and then you reflected it across the x-axis, which is the red one, is what we did there, right? Okay. All right. So that's how that goes. Let's go to example number 2. Example number 2, find the period of each function and use the language of the transformation to describe the graphs, how the graphs are related. So again, we're going to start with y1 is equal to sine x, and then b is going to be y2 is equal to negative 2 sine x over 3. Okay, so let's go ahead and everybody grab your calculator. Go ahead and graph this guy here first. Make sure you have to be in the radian mode, right? Make sure you're in the radian mode. And go ahead and graph this. Okay, so this guy here, we already did. Okay, if I didn't have this, if it was, let's see if we can go ahead and graph this guy first. If I graph this guy first, what do I get? I started with, over here, I started with y is equal to sine x, right? Then I'm going to do negative 2, which means I'm going to do the same thing I did before over here. I'm going to vertically stretch it by 2 now, right? So it's going to be from 2 to negative 2. But then I have a negative here, so I'm going to take these values. I have to do the negative, so it's going to be the reflection across the x-axis again. So it's going to look like this, right? This is what we're going to look like. Okay, so this is where we're at. But then I have to do one more step. Instead of x, it is x divided by 3. Okay, and this is basically a horizontal stretch of 3. Okay. So everybody go ahead and see if you can plot that. I want you to plot this and verify that you indeed do get the red one stretched out by 3. Okay? So everybody go ahead and do that, please. Okay, was everybody able to get that? Was everybody able to see that it was horizontally stretched out by 3 now? Everybody got that? Okay, good. Hunter got it, good. Anybody else? Okay. A thumbs up would be nice, just to know that I know that you've got it. All right, looks like most of you got it, so we'll move on. All right, now let's go ahead and see if we can do C. On C, we're going to do 3 sine of negative 2x, okay? The 3 part is pretty simple, right? The 3 part is we're going to vertically stretch it by 3. So the amplitude now is, instead of 1, it is 3. So that was pretty simple. But what is this negative 2x thing here, okay? So let's figure out the negative for right now, okay? The 2x is basically now, instead of a horizontal stretch, I'm going to do a horizontal shrink. So I'm going to go ahead and compress it by 2, okay? So I'm going to stretch it by 3 vertically, then I can compress it by 2 horizontally. Then I have this negative here, and that is where instead of x is, I put negative x. That means that I have reflected it across the y-axis. Okay, so let's go ahead and verify that. See if you can get that. Again, if you were able to get that and verify that, please just give me a thumbs up so that I know that you got there. So Kyle and Olivia are still working on it. Sam. Okay, you have to be careful with the parentheses here too in this one. Okay. All right, so we're gonna move on. Let's go on, and so let's see if we can do example number 3. Example number 3, we have find the frequency of the function that. So I have f of x is equal to 4 sine 2x over 3. So this is example number 3, and I want to find the frequency. So the easiest way to do this is finding the period first. You find the period first. The period is going to be equal to 2 pi over b. So b here being what? What is the value of b? The b is 2 over 3, right? So I'm going to multiply everything by 3, top and bottom by 3. The 3's go away. 2's cancel out, so I have 3 pi. My period is 3 pi, which means the frequency is going to be equal to 1 over 3 pi, because it is the reciprocal of the period. Okay. All right. We're good there. Let's move on to example number 4. Let's do example number 4. As you can see, it's slowly starting to become a little more complicated as we add on the different transformations and things like that, right? So in example number 4, we have write the cosine function as a phase shift from the sine function, okay? So I'm going to start with the sine function. I'm going to start with this guy. And I want to end up with a cosine function, which is going to look like this guy. Okay, I want to end up with this guy. So what did I do? I took the black guy and I moved it to the left. I moved it to the left, right? I shifted it to the left. So but I shifted to the left how much? I shifted to the left by pi over 2, right? So the cosine x is the same as like taking the sine function, and instead of x, I'm moving it to the left, so it's going to look like this. Okay, so that would be the first one. And the second one is now I'm going to go from the cosine function to the sine function. So sine of x is going to be equal to cosine x, but I'm going to shift it, right? I'm going to start from the cosine function. I'm going to start from the cosine, the red one. I have to go this way now. I have to go this way, pi over 2. So I'm going to the right, which means it's going to look like that. Okay. All right, there you go. So that's that. And okay, let's go ahead and stop there. And we will finish up 5, 6, and 7 when we come back. All right.